This video is going to be for homework 13. Wait, no, homework 14, excuse me. This will be the last homework for exam 2. Homework 14 is going to be covering linear equations, which is more graphing. So first things first, make sure you go back to the last homework, homework 13. Today we're going to be building off the concepts. Last time we talked about how to plot points, how to, find points, right? If they were asked us to give, here's an equation, find some points, we all talked about that. So make sure you're comfortable with that. What we're going to be talking about today is graphing linear lines. Remember, we're always going to have the X and the Y axis, just like we talked about last time. And linear lines, linear meaning lines, linear line is a somewhat redundant phrase. Linear equations produce lines is what I should have said. So we're going to have lines that look like this, they could be anywhere, they could look like anything, but they're going to be straight, and that's the point. Okay? So homework 14, we're talking about linear equations, straight lines. So in the last homework, there was a couple problems where they gave you an equation, you had to plug in some points, and it ended up being that kind of U-shaped thing we talked about, right? Just to remind you here, something like that, right? The parabola, that's not going to be something we're worried about going forward. They just use that as an example in homework 13. So just to emphasize, really in this class, when we do graphing, we're sticking 100% to straight lines, okay? So the main way we graph straight lines is what's called y equals mx plus b. Some of y'all were already emailing me asking me about this. So yeah, if you know what this is, that's what we're going to be doing today. This is called it's not, I was going to say standard form, but standard form actually means something else. This is the slope-intercept form. Even though it sort of is the standard, there actually is something called standard form, so don't call it that. It's called slope-intercept form, all right? A lot of people call it y equals mx plus b. And what this means is, m is just a number, b is just a number. And the idea is if we can get an equation to look like this, and I'll show you some examples in a minute with actual numbers in them, then the graphing is actually pretty easy. And that's a beautiful thing. Graphing can be a little bit of a pain. You saw yesterday when you're plugging in points, it can be kind of labor intensive. It can be kind of heavy on the computation. You got to plug this into x squared, and then you're going to do all this stuff to it, right? So this is actually going to be the easiest way to graph with y equals mx plus b. It's not always possible, but the idea here is if we can get it in this format, and on this test, we're going to use this format. In the future, that will change. Then it should be hopefully pretty easy to graph. Let me go ahead and show you what I mean by y equals mx plus b, clarify that a little bit before we actually do any graphing. So y equals mx plus b, also called slope-intercept form. The m is just a number. The b is just a number, okay? So some examples here would be maybe y equals 2x minus 3, right? Where the 2 is the m, right? mx, 2x, and then the b, this could be a positive b or a negative b. I guess I should have mentioned that. It's actually plus or minus b because the b does not have to be positive. It could be a negative number. So if it's positive, put a plus. If it's negative, then, put a minus or negative sign. So the b is negative 3. Don't worry about what the m and the b are. We'll talk about that in just a minute. I just want you to be able to identify them first. And hopefully you can see that that fits in the y equals mx plus b format. Another example might be y equals 1/4 x plus 10. Okay, looks like 1 over 9. We'll just call it 1 over 9 then, because that's what that looks like. 1 over 9x plus 10. The slope is the piece in front of the x, so that's 1 over 9. It's not 1 over 9x, it's 1 over 9. The x is something separate. The m is the slope, so mx. And then here we have the b, which would be 10. So again, right now, I just want you to identify them. You don't need to worry about what they do or how we're going to use them yet. This is right now just simply identification. If I wrote y equals negative x plus 7, what would the slope be here? The m, I keep saying that, I haven't written that down yet, I guess. M is called slope. The m would be still the number in front of the x, so the m or the slope would be negative 1. And the b over here, this would be the 7. So there's always a number here, even if there's nothing written there. If it was just x, then it would be positive 1. Since it's negative x, it's going to be negative 1. We might have something that looks like this. Let's go for that 1/4 this time. Y equals 1/4 x. This is still y equals mx plus b. mx, and then there's a number here. What is it? What could you put here that wouldn't change anything? 0, right? So if there is no b, then the B is 0. This is a key point here. I'm going to make a star here because this is one that messes a lot of people up. Once you get comfortable with y equals mx plus b, you'll be able to graph these no problem. But when we get down to one like this is actually easier than these because the number's 0. You'll see what I mean in a minute. But it throws a lot of people off because they don't recognize this as y equals mx plus b. It is y equals mx. There is a b here because you could write plus 0, right? If someone asked you your age, you could say, oh, I'm 20 plus 0. It'd be kind of awkward, but you could do it. It would be true technically. Couple more examples. What if I had y equals, let's see here, 6 plus 11x? What would the m be and what is the b going to be here? In this case, the m is still 11. It's not actually about which comes first. It's the one in front of the x. So be careful. If they try to trick you, they're going to do, they could do this to you and throw this at you. This is still mx and that's b. They've just been reversed. So it's not about the order. It's not necessarily mx and then b. It's something x and then another number. The other number is always b. The something with the x is always the m. So down here, the something next to the x, the constant 11 next to the variable x means the m is 11 and the b is 6. Take a minute, look these over, make sure all of these make sense to you. Again, I'm not asking that you understand what m and b are yet. I mean, I said m is slope. That's just what it's called because I kept using that word by accident. But in general, you don't need to understand what these do yet. I'm about to talk about that. But for this exercise here, I just want you to be able to identify them because if you can identify them, I mean, honestly, you're halfway home to graphing. Okay, so take a minute and then we'll go ahead and start graphing, or we'll talk about m and b and then we'll do a quick graph and then we'll just start practicing the graphing. All right. Again, as I always say, feel free to pause. You don't have to go at the speed I'm talking. In fact, you probably don't want to or can't. So just take it easy and take your time. So again, just like same thing I've written at the top of the last 3 papers, y equals mx plus or minus b. The m is called the slope, and the b is called the y-intercept. I haven't referred to that as by its name, I don't think, so there it is. The m is called the slope, the b is called a y-intercept. Remember, they are just numbers. The way you can think about this in terms of a graph, right? Like if we were gonna graph, this is something small and kind of generic over here. We have to start somewhere, yeah? Let's just say we wanted to graph a line that looked like that, but we didn't know that was the answer yet. That's what our solution is going to look like, but we're over here starting. Where are you going to start the line? I mean, it has many points, right? But we need a starting point. Otherwise, you're kind of just, left to guess. So the y-intercept is your starting point. The b is your starting point. And we'll talk about what that means specifically in just a moment. The slope is the directions, right? Because let's say I told you we're going to start right here and I come over here on this graph and we start right there. That's great. There's my starting point. What direction do I go in now, right? Think about when you use Google Maps to help you find something, or Apple Maps or whatever. You have to tell it not only where you're at, the starting point, but you have to ask for the directions to where you're going, and that's what the slope is. The slope is the directions, okay? So we'd have a starting point, and then the slope would tell us, oh, you're going to go up this way or down this way or whatever, and then we'd have our line. So just generically speaking, the b, the y-intercept, is the starting point for the graph. Make sure you get what I'm saying here. And the m is the slope or the directions. Again, I haven't told you about how we're going to do that yet, but I just want you to understand where they're going to come from. This number here is going to tell you where to start, and this number here is going to tell you if you're going to go up, down, left, right, and all that kind of stuff, okay? So let's talk about the y-intercept first because it's sort of the easier of the 2 concepts to talk about because it's just a point. So what the heck? Let's try that again. Y-intercept. So again, this is the b, okay? And it is the starting point of the graph. So let's say we had something like y equals 2x plus 3, which I think was one of the early examples we just did a minute ago in terms of identification. The b, the m is 2, right? And the b is 3. The slope is 2, and the y-intercept is 3. So when we come over here, if we wanted to do a graph, and I'll use the graphs, some of y'all said you liked those, so we'll use those again. Just for right now, I'm going to freehand it, but in a minute we'll use the actual pre-drawn graphs. But if I wanted to graph this, I need to start somewhere, and this b tells me I'm starting at 3, okay? Now here's the thing though, if you're thinking about this, that's still not really clear, is it? Because think about a graph. It counts off the numbers in all directions, right? Like we talked about 1, 2, 3, -1, -2, -3, 4, and all that stuff. Where's 3 on the graph? Sort of an ambiguous statement, right? Because I didn't say 3 on the X and I didn't say 3 on the Y. I just said 3. There's a 3 here, 1, 2, 3. And there's a 3 up here, 1, 2, 3. They're not over here because this would be -3, right? Which is not what we're talking about. It's not down here because that would be -3. So that's not what we're talking about. 3 either on the X or 3 on the Y. You've got to make sure you know which. And that's why we call it the Y-intercept. The B starts on the Y. I'm giving you a lot of information right off the bat. Once we start practicing, this will hopefully become pretty routine. Okay, so this number, the B, is the starting point, and it always starts on the Y. It's always on the Y-intercept, the Y-axis, I guess, to be technical. Okay, so don't ever. I mean, this is the number one mistake with graphing, y'all. If you're worried about messing up the graphing on a test, the number one thing people do is start on the X. If you're graphing a line and you have your B, the B is going to tell you to start on the Y. So that line would start right there at 3. Okay. Now we'll talk about the slope in a minute, but this one would actually go up like this. We'll talk about that on the next page. But I just want you to understand the starting point is always on the Y. Okay. So that's really crucial. I know I've said it like 15 times in 1 minute, but it's really, really important that you understand that. Because again, the most common mistake is starting the graph in the wrong place. Okay. The easy part, because the slope is kind of the annoying part. The easy part is just where you start it. Don't mess that up. It's important that you make sure you get that distinction. So we're just kind of building up our understanding here. So again, just rewriting what we just said. The B is the Y-intercept. And that is a starting point. And as the name would imply, it starts on the Y, and we should say, to be technical, it starts on the Y-axis. Okay? So let's do it. We're going to graph a whole one this time, but we'll start with that again. Let's say Y equals 2 over 3x minus 1. Okay? First, identify your M and your B. Your M here would be 2/3. Your B here would be -1. Okay, so what this means is the B is our starting point. We're going to start at -1. Where's -1 on the graph? Well, again, remember, if you just say -1, you're not being super clear because there's -1 in a couple of places. There's a -1 right here, right? 0 in the middle, down 1, that's -1. There's -1 here, 0 in the middle, left 1, there's -1. Which one am I talking about? We're talking about the one that's on the Y-axis. Do not get this backwards. So we're going to start this at -1 on the Y-axis, okay? If you're starting on the X-axis and you're doing MX plus B, it's wrong immediately. I can just guarantee it'll be wrong. So again, I know I'm being sort of redundant here and I keep saying the same thing over and over again. It's that important. Start the graph on the Y-axis, wherever that number tells you to start it at, okay? Take a minute, make sure you're cool, and then we're going to talk about the slope. All right, so we got our starting point of -1. Now our slope is 2/3, okay? So over here, let's talk about how to deal with slope. Again, you guys have probably already heard about this. Some of you, again, emailed me kind of asking me if this is what we were getting into. The slope, and we're not going to talk about where it comes from today. That's actually something we're going to work on test 3. So you don't need to worry about, how this is generated. This is strictly just a definition. The slope is the M, and it is the directions. And the way the slope is interpreted is the change in Y over the change in X. That is the official definition of the slope. Now, think about what that means. Which direction does the Y go? Up and down, yeah? The Y-axis, right? We're talking about the Y-axis and the X-axis. The Y's go up and down. So when I say the change in the Y, what I mean is, did it change up or did it change down? The X-axis goes left and right. So when I say the change in the X, what I mean is, did it go left or did it go right? This is known as, I'm sure you guys have been sitting here screaming this, rise over run. I actually don't like the term rise and run because rise implies what? If I told you your grade was rising, what would you imply? What am I telling you? It's going up, right? These lines do not always go up. So personally, I don't like the term rise and run because rise implies up. I'm going to pretty much always say change in Y over change in X because that is officially what it is. If you look in an advanced math book or if you go into college algebra or something, it'll look like this. This is how they write it a lot of the time. Okay? So change in y over change in x. And just think about this for a second. If you were asking somebody directions, they might say you need to go 2 miles north, which we would kind of think about as up, and 3 miles west, which we would kind of think about as left, right? That's all this is saying. So when we come up to our slope over here, which was 2/3, 2 over 3, that means that the change in y, which is, again, this is just, excuse me, I wrote this backwards down here, didn't I? Change in y over change in x. Stop and make sure you got this correct in your notes. This is a crucial error I just wrote down here. I said it right, I think, but I wrote it wrong. It's change in y over change in x, just like it says here. Be careful. So change in y over change in x. And that means our change in y was +2. So think about what that means. It means you go up 2, right? If I told you your y is going to change by +2, wouldn't that mean up 2? And then let's go down here to the change in the x. I told you that your x is going to change, and that's what the little delta, the little sign means change. If I told you that the x was going to change by +3, because these are both positive numbers, wouldn't you say, well, that's going to be going to the right, because that's the way x goes when it's positive, 3. My friends, you have your directions now. You're going to go up 2 and right 3. So think about it. We're going to go up 2 and we're going to go right 3. From where? From the starting point. And that's the whole picture. You have a starting point, -1. And now from that point, we're going to use this slope to tell us to go up 2 and right 3 at the same, all at once now. So up 2, and then also right 1, 2, 3. Up 2, and then at the same time, don't put a point here. It's all in one thing. Up 2, and then also right 1, 2, 3. Our next point would be right there. Now you have enough to make your line. I don't draw straight lines well, so, bear with me there. But okay, think about what just happened. And again, when we start cranking these out in a minute, because that's how we're going to end this, we're just going to sit here and do 4, 5, 6 examples, because once you get comfortable, this is very fast. This took like 10 minutes because we had to break down every single piece. Once you get comfortable with how this works, it's going to fly, okay? So if you feel a little overwhelmed with the information, if this was somewhat new to you and I kind of hit you with a lot, just keep watching. Once we start doing these in rotation, it's going to get a little bit easier. So one more time, the B is the y-intercept, and that is the starting point. And it always is going to start on the y-axis. The M is the slope, which is, you can think about as the directions. The official definition for slope is the change in the y over the change in the x, which means, are you going up and down, or are you going left and right? If you want to call it rise over run, that's fine. Just be aware that they don't always rise, okay? So let's go ahead and just start graphing these. Because this is the majority of the homework, is graph. Just here's an equation, graph it. Here's an equation, graph it. Here's an equation, graph it. Okay. So on this first one over here, let's do y equals 3x minus 1. Okay. Just something fairly simple, nothing crazy with the numbers. All right. Let me see if I can get it to zoom in any better on those numbers. Not really. Hopefully those, you guys said they showed up okay last time, so hopefully they're fine now. So let's identify our pieces. Our M here is 3. And our B here is -1. First things first, always identify your pieces, okay? Now remember, what did we say? Just one more time, I'll write it up at the top. This is the y-intercept, or the starting point. Again, keep saying the same thing, because that's all you really need to know here. And the M is the slope, which is the change in y over the change in x. Again, that's just the shorthand abbreviation, okay? So we're going to start where? 3 or -1? Well, -1, just like like when we did a minute ago. Start here at -1 on the what? -1 on the x or -1 on the y? These always start on the y, so this is going to be -1 on the y, which is going to be right there. Okay? Now our slope is 3. Actually going to do this down here. Our slope is 3, and we need it to look like change in y over change in x. Now don't make a mistake here. The slope is 3. You don't need to turn this into a fraction to tell me what the slope is. If I say, what's the slope? You just say 3. But if you want to interpret it, you need to have it as a fraction. So how can we turn 3 into a fraction? Any number can be turned into a fraction by putting 1 underneath, right? So that's it. If you don't have a fraction as your slope, just put it over 1 in terms of how to interpret it. Again, don't tell me the slope is 3 over 1. That's not true. The slope is 3. But when you want to work with it, you need to think about it as a fraction. So 3 is the change in y, 1 is the change in x. Think about what this means. Y's go up, or down? That's a positive 3, so that would tell me to go up 3. X's go left and right. That's a positive X, so that's going to tell me to go to the right 1. Okay, review the last video if you're not clear on the directions here. Up 3, right 1. From where? From the -1 that we started at. So I'm going to go up 3, 1, 2, 3, and then right 1. And there's my next point. Up 1, 2, 3, and also at the same time, right 1. Don't put a point here and then there. It's only, you know what I mean? It's all one motion. Up 1, 2, 3, right 1. For the most part, you'll be doing this on the computer, so it'll be a little bit easier for y'all. And then you can do it again if you want. Up 1, 2, 3, right 1. See, 1, 2, 3, right 1, and we can keep doing it as many times as we want. And the point will continue to fall on the line because that's the whole idea, right? This should be one line. These points shouldn't start going off and curving because we're drawing a straight line because this is y equals mx plus b. And y equals mx plus b always make straight lines. So that's what that one would look like. All right, let's try to do the next one a little bit quicker. Again, it's not a rush, so if you want to pause and take your time, that's fine. But on the test, you know, if you get these questions, these should be the ones that are real quick and easy. Those exponents or maybe those charts we had to do might be the stuff that takes you a little bit longer. Let's say we did y equals -3/4 x. Let me write that again down here. Y equals -3/4 x plus 3. Okay. Now notice I've got the negative in the top. We'll talk about that in a minute. But for now, just to keep it from getting too crazy, we'll leave it there. So our m is -3/4. And our b is 3. So what does that mean? Where are we going to start? At 3. 1, 2, 3 on the y. Remember, the b is the y-intercept, so we're going to start on the y-axis. Up 1, 2, 3, and there's my starting point. Okay? Now, down here we have the change in y over the change in the x. -3 on the y would not be up, right? If I told you the change in y was -3, that would be down 3. If I told you the 4 was the change in the x, and remember, this 4 is not negative. If it was 2 negatives, this thing would be positive, right? That's a positive 4, so that's still going to be right 4 on the x. Think about what I'm saying here. Negative on the y, that's down, so down 3. Positive on the x, that's still to the right, so that's right 4. So we're going to go down 1, 2, 3, and right 1, 2, 3, 4, and there's that point. And again, you know, if at this point you want to do it again, you can. Down 1, 2, 3, right 1, 2, 3, 4. I think, if I'm not mistaken, the computer program y'all use will simply just complete the line after 2 points. But, you know, if you're doing it by hand, you probably want to have several points. If we were doing this in a paper pencil scenario, you would definitely want to have extra points just to keep it clean. And so that's what that line looks like. Because you know it goes in both directions. Once you know what it looks like going in one direction, you just draw it back the other direction. Okay? So there's 2 examples. Pretty, you know, that was a little bit quicker. We did 2 examples this time, and the time it took us to do 1. Now we're going to kind of step it up a little even faster. The next one we're just going to try to knock out, and hopefully you'll see that these are pretty quick. Once you know what you're doing, once you get comfortable with mx plus b, it should hopefully come pretty quick to you. Let's try y equals, let's do this. Let's do it like this. Let's throw one more little curveball in there, kind of get the last ugly thing out of the way. Once you do this, everything else should be fine. So -1/6x plus 7. Let's go ahead and do this one. Our m is -1/6. And notice this time, the negative is not on the top or the bottom. It's just off to the side. Remember, we've talked about this. Go back to the fraction lecture. Negatives can be on the top of the fraction. Negatives can be on the bottom of the fraction, or they can be off to the side, and it's all the same thing. So be prepared. In the last one, the negative was stuck on top for you. Here, it's kind of just sitting ambiguously off to the side. So we're going to need to talk about that. And the b is 7. Okay? So start with the easy thing. Where do I start? I start at wherever the b is, and it's always on the y-axis. So I'm going to start at 7. 1, 2, 3, 4, 5, 6, 7. Right there. Okay? Now the slope. Let's do that down here. My slope is -1/6. Now remember, let's see. I'll stick it up here. Remember, this could be -1/6, which is the same thing as 1/-6, which is the same thing as -1/6 with the negatives just off to the side. Sorry. The negative could be on the top, the bottom, or off to the side. They're all the same thing. I'm going to tell you to always put it on the top. It is not a rule, but that way it's always in the same place and you don't have to sit there and worry about it. So if they put it in the bottom, just move it to the top. If they put it off to the side, just move it to the top. So down here, I'm going to rewrite this as -1/6. You can put it in the bottom. And you might say, well, wouldn't that make the directions go differently? Yes, it would, but it's going to end up being the same line. You'll see what I mean in just a second. So we started at 7, and now we have a slope of -1/6. And again, I put that negative on the top because I don't want it sitting off to the side where I don't know where it goes. So I just pick the top. You could put it on the bottom if you want. The change in y over the change in x. So the change in y would be -1. That'd be down 1. And the change in x would be +6. Be careful, because that's not two negatives. And that would be right 6. So I'm going to go down 1, right 1, 2, 3, 4, 5, 6. And again, you could keep doing that if you want to. Down 1 over 1, 2, 3, 4, 5, 6, somewhere out here. Okay. Now, you don't need to do this every time. I'm only going to do this one time just to show you. What happens if you did put it on the bottom? And if you don't want to know, if you're one of those people who doesn't want to see extra information, just skip past it because you got the line now. The line's already finished, right? We already got our line. It's going to look something like this, right? Okay. Ugh, that was really bad. Sorry. You guys get the idea though. I should probably get a ruler or something here. So if the top was +1, wouldn't that be up 1? And if the 6 was negative, and that's the change in x, wouldn't that be left 6? And you might say, well, those are totally different, but think about it. If you go up 1 and left 6, you're going to end up right over here, which is, if I drew my line normally, is where it should fall. Up 1, left 6 would be right here, which is, if my line was drawn straight, that's where it would fall, okay? So you can go either direction with it. I don't recommend this because this is just going to end up confusing you. So honestly, I would stay away from doing that. I would just put the negative up in the top. And again, apologies for the crooked line. That's really unacceptable. I'm going to have to get a straight edge or something here. All right, so let's try another one. What if I said y equals 4x? Just 4x, nothing else. Let me rewrite that. That looks kind of ugly. Some of y'all have criticized my handwriting and asked me to be a little bit cleaner. So I'm making an attempt. It means I got to scribble stuff out a lot, but I'll do the best I can. Let's say we had y equals 4x. So my m would be 4. No big deal there. What is your b? Where's the starting point on y equals 4x, right? That's the line, or that's the equation. That's what we're trying to graph here. Y equals 4x. So where's your b? Remember, it's 0 if it's not there. So your starting point is 0. Now, where is 0 on the graph? On the y-axis, or well, really either axis, 0 is right here in the middle. So if you don't have a b, the graph starts in the middle. Now, let me make one thing very clear. I actually should have said this earlier. Another mistake people make. Think back to homework 13 for a second. How do you graph a point? You start in the middle, and then you go over to the x, and then you go up on the y, right? Like in homework 13, when you were just graphing points, you would just go start in the middle, and then go to the x, and then go to the y, and there's your point. When you are graphing lines, you do not start in the middle unless it tells you to. This line over here didn't start in the middle, right? This line over here started up here at 7. This line here starts in the middle at 0, not because they all start in the middle, they don't, because the b was 0, okay? So our m being 4, we can think about that as 4 over 1. So our change in y over change in x, the change in y is 4, so that would be up 4. The change in x is +1, so that would be right 1. So we're going to go up 1, 2, 3, 4, and then at the same time, right 1. Up 1, 2, 3, 4, and at the same time, right 1. And that should be our line, nice and clean like that. Hopefully making a little more sense and hopefully getting a little quicker, right? Let's do a couple more examples and then we'll wrap this up. Take a minute, pause, make sure you're clear on these. I'm actually going to get a straight edge for the rest of these because that line there is embarrassingly bad. So take a minute and then we'll move on to the next set. All right, guys, let's go ahead and do a couple more, wrap this up. So that's really the whole homework. This is graphing with y equals mx plus b. Once you get comfortable with it, it should hopefully be pretty quick for you. All right, so let's try to knock these out pretty fast. I have one other thing to say at the end. It is related, though. It's not a new topic. It's just something a little bit, you got to be a little bit careful with. So let's say we had y equals 2/5 x minus 5. Go ahead and think about what that would look like. We're going to try to do this one just bang, 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 right? So my m is 2/5, my b is -5. I would always recommend writing that out at least. You may not want to write all the stuff I did every time, every single problem, but at least write out your m and your b. So our b is going to be -5. We're going to start down here at -1, -2, -3, -4, -5. And my slope is 2/5. And they're both positive, so I don't have to worry about which one's negative or anything like that. The change in y is the top one, 2. So that's what? That's going to tell me to go up 2. And then the change in x is 5, +5. So that's going to tell me to go right 5. This is starting to make some sense, hopefully. So up 2, right 1, 2, 3, 4, 5. And that's where your next point would be. Again, y'all have the benefit of the computer. As soon as you have the 2 points, it's going to draw your line for you. Unfortunately, I do not have that benefit, so I will have to use a bit of a straight edge here. There we go. Look how nice that looks. And there's our line. So it's real simple. Once you get the hang of it, you have your starting point, up 2/5, and you're done. And if you do it again, up 2/1, 2, 3, 4, 5, it should end up back on the same line. That's the whole point. Once you know the slope, it does not change. All right? Let's do one more over here. Let's do y equals... what could we do here? Let's do 1/-7 x plus 8. All right, something like that. Your m is -1/-7. Again, how you do this is up to you. I'm going to go ahead and throw the negative up top just to reiterate that I don't like having the negative anywhere else, so it's your choice. If you want to keep it on the bottom, you can. So our b is 8, so we're going to start up here at 1, 2, 3, 4, 5, 6, 7, 8. And then my slope is going to tell me to go down 1 and right 7. Down 1 and right 7. So down 1 and then right 1, 2, 3, 4, 5, 6, 7. Down 1, 1, 2, 3, 4, 5, 6, 7. Okay? Now what if you kept the negative on the bottom? Well, wouldn't you go, now again, I'm not doing it like this now. I'm saying, what if we kept it up here? How would it be different? It would be the same line, right? That's the beautiful thing. If you want to keep the negative on the bottom, you can. If we did, the top would be +1, telling us to go up 1, and then the bottom would be -7, telling me to go up 1, and then left 1, 2, 3, 4, 5, 6, 7. But my friends, isn't that on the same line? So it doesn't matter. It doesn't matter where you put the negative on the slope. As long as you have it at the top or the bottom, and only in one of them, not both. Kind of missed that point there, but that's all right. Then it'll be fine. So whether you put the negative at the top or the bottom, it does not matter, but do not put it in both, because if you put it in both, 2 negatives is not negative, it would be positive. All right? One other thing I want to mention real quick, and this is just going to be a definition. Okay, this is just going to be definitions. There are two types of lines we haven't talked about yet. Luckily, they're the simplest kind of lines you could possibly be asked to draw. They just don't follow mx plus b. So this will be the last thing we'll talk about today. So there's 2 types of lines. I'm going to call these the special cases, because these are not y equals mx plus b. And what we're talking about here, I'm going to kind of split the paper down the middle. What we're talking about here is horizontal and vertical lines. And this will be pretty quick because these are pretty straightforward. You just got to memorize a couple things. Think back real quick. I'm just going to flash the graphs we've been doing up at you. Look at these graphs. Are any of them horizontal or vertical? No, right? They're all kind of like angled. They're all up and down and left and right and diagonals, right? Every graph we did today was diagonal. So we didn't do a horizontal or vertical line. Can you have them? Yes. And do they follow the same rules? Not really. So horizontal lines, let's make sure we're clear on what horizontal means. Here's our X and Y axis, just like normal, right? A horizontal line would be something like this, right? Some line down here going left to right, like the horizon. That would be a horizontal line. These have a fixed slope, and that slope is 0. Just memorize it. Horizontal lines have a slope of 0. One way a student told me they memorized it, the horizontal has the O in it. Vertical does not have an O in it. Horizontal has an O in it, so that's the one that has the 0 slope. Just memorize it. Because what they're going to do is show you a horizontal line and then just say, what's the slope? And you'll have to know the slope is 0. The thing that makes these a bit of a pain is they have different equations. The equation is not y equals mx plus b. The equation here is going to be y equals some number, and there will be no x. This is important. So, you know, some examples here. It might look like y equals 2. That's a horizontal line. It might look like y equals -1. That's a horizontal line. It might look like y equals -1/3. These are all horizontal lines, okay? So let's say this one up here. Let's put some numbers on this graph. So this line here would be down here at -1, 2, 3, 4, right? This is a horizontal line on the 1, 2, 3, 4 on the y. So the equation for this line here would be y equals -4. So that's really all it is. Horizontal lines don't have x's. You've got to memorize. This is a memorization thing. You really do need to know this going into the test. Horizontal lines do not have x. So if you get a line that has no x in it at all, then you have a horizontal line. You draw a horizontal line wherever this number is. This would be a horizontal line at 2. This would be a horizontal line at -1. And this would be a horizontal line at, you know, -1/3 here, somewhere between 0 and 1. We'll do a couple of these in a minute. I just want to get the general explanation out first. Vertical lines, just so we have a visual idea of what they look like. Something like this, right? Up and down. Okay? They have the slope that is called undefined. It is not, do not say does not exist. That's not correct. I don't want to teach you bad habits. It's not, does not exist. It does have a slope. It's just undefined. Or if I don't know if you say it has a slope, but it is not non-existent. We say it is undefined. So be clear about that. The way I remember this, kind of like UV rays, right? Undefined goes with vertical, UV. Slope is undefined, and the equation is kind of exactly the opposite of a horizontal line. The equation here will be x equals some number, and there will be no y, and that is very important. So for example, it might look like x equals 7, x equals -3, x equals 10, could be anything, right? Up here, let's just say this was 1, 2, 3, 4, 5, 6. So the equation on this vertical line would be x equals 1, 2, 3, 4, 5. The equation for that vertical line right there would be x equals 5, okay? Just so you guys have a quick understanding. So 3 things you need to memorize. You need to memorize the 2 names, vertical, horizontal. You need to memorize what the slopes are between them, horizontal being 0, vertical being undefined. And then you need to recognize what the equations are going to look like. If you're missing the x, you have a horizontal. If you're missing the y, you have a vertical. If you get these backwards, there's not going to be any partial credit on these. You know what I mean? If I say, hey, graph x equals 5 and you graph a horizontal line, that's completely wrong. So while these are the easiest lines to graph because you don't have to worry about slope and all that stuff, they're also easy to mix up. So be careful about that. Take these seriously and don't play loose with this, or you're going to miss questions on the test and be annoyed at yourself afterwards. Okay? So let's practice this real quick, and that'll be the end of the lecture. In the future, guys, this is really what we're going to be doing for the most part in the class. So it's worth maybe like bookmarking lectures 13 and 14, because if later you go back, so I need to review graphing, this is where it all starts, lectures 13 and 14. Okay. Let's say I asked you to graph x equals -7. Right now, you're probably going to need to go back and look. What is this? Is this vertical? Is it horizontal? And all that stuff. By the time the test rolls around, you got to just look at this and know. X equals -7 is a vertical line. Okay. What is the slope? Because they might just ask you that, right? They might just say straight up, what's the slope? The slope for any vertical line is undefined, right? It goes straight up into the air. It's like a wall. It doesn't have a slope. Think about slope like it would be in a mountain. How much it leans over. A wall that goes straight up into the air, you couldn't really even say what kind of slope that had. So we say undefined. There's actually a reason it's undefined, but we don't need to get into it right now. It's not really in the scope of the class. It is not made up, though. There is a reason we say this. X equals -7. This will be a vertical line at -7. So over here, -1, 2, 3, 4, 5, 6, 7. Start there. Now notice this is not y equals mx plus b. I made a big deal about never starting on the x-axis, but that was for y equals mx plus b. This is not y equals mx plus b. This is a vertical line. So we just start at -7, and then on the computer, you'll just put another point anywhere on the line, and it'll draw a nice vertical line there at -7. So be careful. You got to recognize, I mean, this was easy once I knew what it was, but you got to recognize what this is. That's the key. Over here, let's say I said y equals 3. Remember, and we're only going to do y equals 3, but this is not the same as y equals 3x. This is mx plus b, right? Y equals mx plus b. Because you could put a plus 0, 3x plus 0, and that's mx plus b. That is not what's happening here. Here, this is y equals 3. There is no x. That's how you know this is a horizontal line at 3. The slope of a horizontal line, of any horizontal line, is 0. So this is a horizontal line. We write that up here. Horizontal line at 3 on the y. 1, 2, 3 on the y. On the computer, you'll just pick any other point on the line, but it is a horizontal line right there. Okay? So the vertical, horizontal are easy to graph. They're the easiest lines to graph. They just are not so easy to recognize, or they're easy to recognize, but they're also easy to get mixed up. So I would recommend spending a little extra time on the vertical, horizontal, just to make sure you have your definitions right. Hopefully, you know, maybe it started off a little bit much, but hopefully by the end here, this is making sense and you can kind of crank through these pretty quickly, okay? And I will see you guys on the next one.